All right, it's 11 o'clock. So this is the Kotlin cross-platform talk. I know there's a bit of a misprint in your paper. So if you did want the JavaScript one, it's over that way. I hope he tells the people the same thing, 'cause I wouldn't want to be in a JavaScript talk personally, but that's me. This is cross-platform. That's the title of my talk. Really bad at names. Got two kids that remind me of that all the time. But it is using Kotlin. So I want to get some input from you guys real quick. Is there something that if you have one of it, it's better to have two? Just you like to have more of something? Just money? Okay, yeah. Good. Twice the money is pretty good. Anybody else? Bacon? Yeah? All right. I thought beer would come up. Bacon's another one, yeah. But to have 2 times the bacon, you actually have to spend 2 times the money, right? Nobody likes to pay 2 times for something if they can avoid it. It's like why we love 50% off sales, why we get like buy one, get one. But the thing is that the experience matters, right? If I see a sign that says buy one, get one for a beer, and I get 2 glasses that are half full, that's really not a good user experience. If I use a cross-platform tool, say something like PhoneGap, and it doesn't let me provide a good user experience, you get things like this. Users are not going to want to use this. They will if they have to. A lot of cross-platform technologies today, they instead of bringing like these whole environments that go across platforms, they'll bring a language to both platforms, and they claim to be native, and they kind of are. React Native, and it brought Flutter along with it. All right, so we got all these other kinds of languages out there that you can actually run on your phone, your iPhone or your Android phone. They tend to run into issues where they play really nice on one, or they don't do so well on the other. Typically, bringing something that's natively compiled like Go or Rust or C++ into an Android world, you have to deal with JNI, and you don't want to deal with JNI. It's a pretty horrible experience. So really, it's just not fun to do any of this stuff. There's kind of an elephant in the room. I didn't mention Swift yet, and so Swift, it's open source, and it does run on Android, and it runs on Linux. It's pretty cool. But it's not a JVM language at all. So if you want to write something in Swift and deploy it on your Android device and call it from Android code, you have to deal with JNI again. And it's sad. Swift is a pretty good language. All 4 major versions that were not backward compatible were pretty good. So we're going to be talking about Kotlin. Kotlin is a first-class JVM language. It has first-class support on Android. Google announced that at I/O in 2017. They now have most of their examples in Kotlin. It's the first language I could say I learned by copying and pasting, because I started a new Android project and accidentally ticked the use Kotlin box, and then just started copy-pasting a bunch of Java code into the window, and it would convert it for me. So that's pretty damn cool. Got to give the Jetbrains guys props for that. For about a year now, it's also been able to create native binaries. So I can actually take it and use a compiler and produce machine code, x86 or 64, ARM32, ARM 64, The Kotlin Conf app last year actually was for iOS and Android. Used the same code base generally, and nobody knew. It was pretty cool. It is native to iOS, and it does not use a JVM because that's something Apple doesn't let you do. It doesn't let you have virtual machines on their phones. That was to kill Flash, by the way. Worked pretty well. Thank you. So yeah, it doesn't suck. That's the one thing that I like about Kotlin. It's not bad. Apple said, what would Objective-C look like without C? And we got Swift, all the 4 major versions of it each time. Kotlin said, JetBrains said, what would Kotlin look like without the JVM? And it's just Kotlin. It is a little bit different, but you could pretty much take the same code and run it in both places. So Kotlin Native is the name of the project that allows you to compile native code with Kotlin. If you need to Google it, that's what you would Google. It focuses on concurrency, so it does have a little bit of a difference from JVM style stuff. You can't share and mutate variables between threads, for instance. You're right, you should not do that. It's instead of garbage collected, it's reference counted. So if an object has a number of references, and they go up as things reference it, and they go back down as those objects go away. When it reaches 0, the objects deallocate themselves. There's no real garbage collection, although it does have some cycle detection built into it. So if 2 objects are referring to each other, their reference count would never actually go to 0, and the Kotlin runtime will figure that out and actually get rid of it for you. It also has a concept of weak references. I don't know if that's over in the JVM side or not. I actually come at Kotlin from the iOS direction, which is probably different than a lot of people. It uses LLVM to create the native code. That's the same compiler that Objective-C uses in CLang. It's the same one that Swift actually uses. There's all these different front ends to LLVM, and Kotlin's just another one of those. And really nice thing about LLVM is that it compiles to a whole lot of different targets. So pretty much wherever LLVM goes, Kotlin can go. So Raspberry Pis, for instance, I believe they got some support for embedded processors, like one of the STM ones. So another thing is that it's integrated with the Kotlin 1.3 compiler. Before, in the early days, it was kind of a separate thing that they were tracking the 1.2 features, and the new Kotlin 1.3 compiler is more of a front end that produces like some kind of intermediate language that then gets compiled into whatever target, so JVM, JavaScript, LLVM as well. So it's always going to be up to date with Kotlin. If you haven't seen some of the features in 1.3, they're pretty cool. And for iOS, well, actually for everything, but it can produce standalone executables and standalone, well, not standalone, but shared libraries that are either static or dynamic. And for Mac and iOS, it produces frameworks, which is very important for iOS developers. It doesn't really have cross-compilation. It's very minor. So if I'm on a Windows machine, for instance, I cannot compile to a Linux target. Same with Mac. You're not going to be able to develop iOS apps in Kotlin on your Windows machine. Sorry. You can. The basic limited cross-compilation it has is Linux to Android and Mac to iOS. So it's you wouldn't really count that as full-on cross-compilation. Said earlier that experience does matter. So what's it look like for iOS? You get to use one of your favorite IDEs to edit the code. So you can use IntelliJ or you can use Android Studio 3.2. You just have to go into the Kotlin preference screen and under the languages and change it to use the 1.3 EAP, at least for now. And they're really close to getting that out the door, so that should change soon. It interops via the Objective-C protocol. So it talks to Objective-C the way anything else, the way Objective-C talks to itself. That means Kotlin can talk to Objective-C, Objective-C can talk to Kotlin things. I can pass a Kotlin object into the Objective-C runtime and it'll use it. It's not a problem. If you want to talk to Swift, you have to go through that little bridging layer. So Swift kind of works the same way in that whenever it has to talk to the iOS subsystem or Mac OS system, it's using Objective-C. And same thing if it has to pass an object into the runtime. You have to decorate those classes with this little add Objective-C decorator. In Kotlin, you don't have to have any kind of attribute like that, but that's the way it does work. So consequently, you can use generics, but it's limited really to how Objective-C supports generics. It has a little bit of unofficial support for just regular generic types, but that's not really well used. It does have it for collections like dictionaries and arrays. So my dictionaries and arrays can have generic types, but that's it. It's basically erased at runtime, a lot like Java does. So if you want to use it from Swift in a generic sense, you're really just going to be passing around objects for the most part. Just a real quick aside, I used to think that Kotlin was just like this language that Java programmers used because they didn't want to type semicolons and they wanted like real properties and stuff. I was digging into some of the runtime stuff earlier this week, and I came across a keyword as the lazy keyword. And I found out that that's actually implemented as a top-level function. And the way it's implemented is the compiler has some support for delegating the storage of that property to another object. And that lazy function just implements that. And I thought, wow, that is really crazy. That must be something cool in 1.3. It's in 1.1. They actually do push the bar more than I thought they did. Definitely found a new appreciation for Kotlin. So this is what it does look like on iOS, or if you're calling iOS code. This is shared preferences in Android, basically. So setting a key value store, I have my named parameters, which is more common to have in Objective-C. And instead of using colons, we use the equal sign. It's actually not too bad for somebody who's used to Objective-C or Swift. More used to hitting the colon key rather than going up for the equals, but it's a small adjustment. This code really doesn't look that much different if I was to write that in Swift. Definitely would have more square brackets for Objective-C. And this code is actually in an app I have on the App Store, so you can ship apps with this. Let's review real quick. So duplication, it's basically why we can't have nice things. You know, we're always, if we have to spend $2 for that pack, for those 2 packs of bacon, we can't have a nice car. Most cross-platform solutions, they kind of fall short, don't look quite right. And Kotlin is cool. So is it cooler than Swift? Maybe. Yeah. Yeah, in Swift, I can program with Xcode, and I have all my completion, and I have interface builder, so I can make my UIs and everything. So, you know, I don't really want to give up those tools, and you really don't have to. My recommendation would be that you pretty much build everything in Kotlin up to the point where you're going to hit your UI. So if I got my view controllers in Swift or my activities in Android, all that stuff would be native. So I can use the Jetpack components on Android, or I'll just use a straight LLVM framework or something, or RX Swift on the Swift side. And then everything below that, I would put in Kotlin. So has anybody written any or worked on any projects where where it was like C and you're sharing it between multiple platforms and you get littered with macros and if-defs, and it's pretty horrible, right? We don't have to do that with Kotlin. That's the good news. The Jetbrains guys, they have a thing called Kotlin Multiplatform. Not this platform. Kotlin Multiplatform is basically a set of compiler features and a Gradle plugin. It seems a little complicated, at least for me, because anything Gradle is complicated. I hear people laughing. Glad I'm not alone. You basically set up a set of common code, and that has all of your logic that you would share across your platforms. In that common code, you can reference pretty much anything that's in the common or the Kotlin runtime. If you need to go outside of that, well, you can reference other common libraries as well. But if you need to go outside of that, you create platform-specific code. And the way you do that is they have this thing called expect and actual classes. It's kind of like a stub and an implementation. It's not really an abstract base class or an interface or anything like that. It looks like an interface when you declare it in your common module. So you just have like a class that says expect this, expect that, and then, but you can't add any functionality to that might be common to both platforms or all platforms. So there is an open issue for that part. But then you actually write your stubs, or you fulfill your obligations in your common platform modules. So if I need something like a UUID generator, I can use the JVM version of that, or I can use the Mac OS version of that in my different platform modules. The Gradle DSL, thankfully they revamped it recently. It was a little rough when it first came out. It's gotten a lot simpler. You define a set of platforms and their targets, and then source sets, and you tell it that a source set will go to a specific platform. So you can actually have one source set that maybe you share to a couple of different platforms if it's, say, Android and JVM only stuff. For the most part, you wouldn't share a whole lot of source sets between each other, but if you have something that's somewhat common, you can do that. So yeah, the source sets themselves, they can depend on other common libraries. For instance, there's a HTTP client in the KTOR project, which is a Kotlin web server framework, but they also have a client library. And you can say your code depends on that code, and then it gets brought in at compile time. And you can also depend on platform-specific libraries. So if I have something like maybe Room or something, I can depend on that in my Android module. And if I really want to, I can depend on some library that maybe tries to make core data easier to use in my iOS side. Your artifacts can be publishable to Maven, which is fine, but they're not really publishable to CocoaPods directly, which is kind of the iOS way of sharing code or libraries. But typically, you share what common libraries, Kotlin common libraries through another means. They have a specific format called klib, which is just it's kind of a zipped up file of halfway compiled code. Your project structure looks a little bit like this. So you have a common folder that would have everything that would be common across your platforms. And then if I needed, and that can have my expect classes in there. So if I need to call something like maybe I need to write out to a database, there's no real great common library for writing to a database yet. There's one for like a SQLite thing that's coming, but SQLite across platforms is kind of crazy. But I can declare an interface, an expected class in my common set there, and then down below in my native or JVM versions or Android versions, actually implement that like repository interface. So it works out pretty well. I like to have a little demo and show off a little bit, tell you guys that it actually works. And I wanted to do something that was more than just like a trivial example. So let's do this. And we have an Android app here, and we have a iOS app here. Oh, what happened here? There we go. Basically, I can tap that, and if the network is happy, which it didn't seem to be, it would bring up another joke. So this is actually going out to just a public API that has Chuck Norris jokes in it. And let me pull up. There's my Android app right there. The common code, which would be here in the app folder. This one doesn't really make use of the expect actual classes a lot, because most of it's really able to be done. Actually, it's all able to be done in the straight up Kotlin runtime and the various common libraries now. The first time I did this one, I had to actually use that a lot more. That was like 3 months ago, and things are really changing fast in this. But I have a basic joke class, and it's using the Kotlin X serialization library, which is another common platform module. It can do like JSON and a few other formats, but the one I was more interested in was just JSON. And it works with some decorators on there, on your class names and whatnot. We have did have to write a special serializer right now, because on iOS it defaults to the wrong character set, and you get a little complaint there at runtime, which is a little bit of a problem, because my unit test ran fine on the command line for JVM. It all worked great. and I deployed it to the simulator, and boom, blew up. I'm like, what's wrong? It works, right? So the debugging experience right now is pretty weak. It took a little while to kind of go through and figure out what was wrong. But here we just have a API client that calls out to the network, calls out to this website, and it's using the KTOR HTTP client stuff. So I don't have to, previously I had to kind of make that one of my expected classes where it would call out to the network. Now I don't have to do that. And that client uses coroutines. So my code is really pretty simple. I have my suspend function, and I build up a URL. You can add some parameters to it, and then call the accept method on there. And that suspends at runtime and goes out, makes the call. When it comes back, it comes back. You can't call these functions, though, from iOS, because Objective-C has no idea what a coroutine is and what a suspending function is. So I do have a second interface into that module that takes a completion block. So it's not as pretty as it could be. If you look at the Kotlin conference app, they use a MVP framework, or not framework, but style. So it's a model view presenter, and all of the asynchronous stuff, you kick that off in the presenter's code, and then the presenter then comes back and says, hey, go ahead and display this list of things, so you don't have to deal with callbacks in that particular style. It's not the style I like to code in, so I prefer more of the MVVM approach. And so we have to kind of work around that a little bit. But it's not too hard. I have a function to launch off the coroutine, catch any errors, display the errors, and then this parses or takes the message back. The parsing is actually done down in this level. So I have some classes, more classes that actually represent the message that come back from the service. So this took about a weekend for me to figure out, mostly because the libraries are a little bit in flux right now, leading up to the 1.3 release. That should all settle down afterward, hopefully. Just getting the right combination of versions to play with each other properly was most of my trouble, actually. Does anybody have any questions on this or want to see anything? That's not pretty. Let me make that a little bit more legible for you. Is that okay for you guys in the back? Okay. On the iOS side, I have my view controller that basically represents the code to get the view, to get the jokes back and display them. It is talking to a view model, and this is using RX Swift, so I pass in an input observable that says that the joke button's been tapped on. Inside of there, we were subscribing to that input and then just asking for a random joke. And I did write a little wrapper around it so I didn't have to deal with that completion block in my main code. It creates an observable that actually does the call for the API client. and then maps that back to the observable joke result. It's mostly, it looks pretty much familiar, except for like you have to return back some Kotlin things when you don't have void, non-return. So all of that looks pretty good except for that little part. But let's see. Did we ever get a joke? No. That would be why. Let's try that. There we go. So we got some jokes. I would say this has about 80% of the code shared between Kotlin, or shared between iOS and Android. The Kotlin app itself does go a little farther because it uses the MVP pattern. But personally, I don't like to do things that kind of go against the grain of the environment I'm working in. And I think MVP is not really the direction that Android's going, and it's a little bit foreign for iOS developers as well. So that's why I went with the MVVM, which is, it's really more MVC, but a lot of stuff is just kind of pulled out of the controller part of it. So let's go back. Definitely not all roses, at least not yet. This is all in beta at this point. The Kotlin native compiler, a few months ago was in alpha, and things would change and maybe break between releases. They're pretty stable as far as that goes at this point, and I believe they're trying to go to 1.0 when 1.3 is released, which should be real soon. The IDE tooling, it does have some room for improvement. I can edit my iOS-specific Kotlin code in IntelliJ or Android Studio. I can kick off a Gradle script to build it, but I can't really run it from there. I can't run my unit tests exactly from either of those, and I can't attach to a debugger with it yet, and that's been a little painful. You can step through your iOS code and stop at the point of where you're going to call something that's in Kotlin, and then step over that. You just can't step into it. It does respond to LLVM debugger commands, so I'm not really that great with that. So I'm not sure exactly how helpful that is, but you can probably dump some stacks if you have to. The performance on the compiler is still on the weak side. They're really focusing on getting things correct and working at this point, and then they're going to speed it up. But that's normal, right? Optimize later. We don't want to do it too early. So, like for instance, it doesn't really cache things that you've already compiled that haven't changed. So it has to rebuild those every time. It is faster than what it was, say, like 3 months ago. So it hasn't been as painful to work with. Typically, what I do in my development cycle is I'll build up a unit test library that I execute just on the JVM side, make sure my logic is working, make sure everything is parsing out correctly or whatever, and then try it out in the wider scope on like iOS or something. So, yeah, the debugging is rough. If you need resources, there are actually a lot of good resources out there. I would start with the Kotlin Lang website. They point you to like multi-platform right away. It's pretty helpful. All of the videos from Kotlin Conf this year are actually now on YouTube in their Jetbrains TV channel that just got released this past week. So that was really quick. I think the conference was the previous weekend, or the previous week. They had some videos out, and now all the rest of them are out there. There's Jake Wharton is in one of them, so I know some of you guys are gonna watch that. Try not to swoon. The Slack channel, they have a Slack channel, and that is very helpful. You can actually communicate to the people that are working on these projects. I've had a number of bugs that were filed just based on conversations I've had with the developers from JetBrains in there. So that's pretty cool. And if you want to see this particular code sample up there, you can download that from my GitHub. And before you guys go to lunch, I want 5 questions. So you're not allowed to leave until I get 5 questions. We'll start with 5.
So your workflow is work in IntelliJ or Android Studio, build up the common code and any specs you have, then switch over to like Xcode, do your UI work, and that just compiles gates and Kotlin is a static library, right? Kotlin stuff?
It's a framework, but yeah. So yeah, that is my workflow right now. For the most part, grab some code, make it work, get tests around it, and then because I'm more comfortable with iOS than Android, I switch over to Xcode, call into my framework, and set up my UI, and then try it out, make sure it works, and then go back over to Android Studio and make my activities or whatever I need to.
You said also that you couldn't run the unit test through IntelliJ yet? Is that command line?
You can run like anything that's not native through IntelliJ, so yeah.
Is there any noticeable performance difference with Kotlin on, say, like iOS versus like Swift?
Yeah, it's not optimized yet. They're not building optimized code. So I don't think I would do a game engine, but you know, a lot of times your performance bottlenecks are your database or your network, and so you're not going to run into too many issues. And it's one of those things that will improve when they get out of beta. Yeah.
From an iOS developer's perspective, if you were handed a Kotlin native binary, would you be comfortable like working with it in your project with little interaction with whoever the developer of that binary was?
So yeah, it works pretty much like any other framework, the binary framework that I would get handed with. It has the umbrella header, and I can go and view any of the methods inside of there. It's just a .h file that has all of the objects and all of the methods on there. I would hope that if somebody's just going to lob something over the wall, I at least have some documentation. The only weird things I would say is like when you pass a number that's boxed in an object, instead of like a NS number, you'll see Kotlin number type. It actually has the word Kotlin before it prefixed, kind of like a CG float, for instance. And the non-void return calls where I have to return this Kotlin unit thing. It's a little weird. Dealing with companion objects, you still have to create an instance of them even though they're there. It's just that always the same instance gets returned back. So things are slightly weird, but not that bad. Need 2 more. Angela.
Yeah, so given your experience over the past year with them changing rapidly, if you could best guess when you think this might be like really production, developer friendly, ready,
Mm-hmm.
do you have any idea when that might be?
I would say it's definitely worth investigating right now. I don't know that I would put it into production unless you're really itching to go until they hit 1.3, and then things are more stabilized. It's kind of a balancing act right now to get your library versions straight. One will work with this version that was compiled with this version of the compiler. Another one is in the later version of the compiler, and then so you just have to kind of match things up. It's a little bit of a dependency hell right now. If you were just doing like a self-contained thing, I would say that'd be okay. But if you want to get a lot of code sharing, then hold off right now.
So you said this can share code between iOS and Android. Can you also like move that code to like the server component if you were building a backend?
Yeah, you could. I was trying to think of great examples where my code would be exactly the same on the server as it would be in the client. Even validations would be a little on the weak side. But yeah, your data models, for instance, will easily share across. As long as you have the same logic and the same needs, yeah, but those tend to serve different purposes, and the sharing might not be as useful. So anybody want to go for a bonus question? All right.
You like to have two
Oh, I like beer.
Okay.
Beer's good. Anything, cars, iPhones, whatever. Yeah.
This may be because I'm late, but I remember seeing that there would be a Kotlin converter, a Java to Kotlin converter. Is that something that's still available?
Yeah, you can take Java sample code and paste it into Android Studio at least, and it'll convert to Kotlin. It may not always be the best Kotlin code, but
It's something to build off of.
yeah.
Okay.
Yeah.
You gotta be kind of careful using that.
Yeah.
And I'm completely ignorant on Kotlin here, but I'm not particularly sure what the problem is Kotlin is probably trying to solve. I feel like at a core, there's commonality, but then I still have to understand how to create UI for Android and UI for iOS.
Yeah. I would.
Is it going to get to a point where I don't have to know those two like design patterns?
I hope not. I hope they don't try to do that. People think that I've got two developers and I'm doing two different projects. Then maybe I can just use something that's cross-platform, and I can just use half the developers. That's definitely not true, but maybe you can cut one of those guys in half and use
That's terrible.
I should have doubled my numbers at first. Yeah, I would say it's like a 75% savings, or not a 50% saving. You still have to have people that are familiar with the end platforms that they're in, and it's the same problem with other things like React Native. Airbnb kind of gave up on it because they had people that were specialized in Android and specialized in iOS, and they couldn't really cross over between the two. So you're not going to save 50%, but a good portion. All right. Anybody else? All right. Thank you, guys.